Now look at this.
What's up, Hippie Bio Penguins? Today we're going to do topic 8.4, effect of density of populations. So what is density? Density is the number of individuals that are going to be found in a certain area or a certain volume. And carrying capacity has to do with the number of individuals that the environment can support. So density-dependent factors depend on the density. So for example, disease. Disease is going to spread more quickly in a more densely populated area than in a less densely populated area, which means more deaths. So density also can have an impact in the birth rates. So if we're in a densely populated area and there's already competition for resources, we're going to see there will be a decrease in the birth rate. Density independent factors are going to affect the population size the exact same regardless of density. Density independent factors, an example, are like natural disasters like a hurricane or a tornado or a flood. Which brings us to the logistic growth model. So instead of having exponential growth where the population can grow indefinitely, now we've reached carrying capacity. K is your carrying capacity, as we said before, the number of individuals that can be supported by the environment. When it reaches that carrying capacity, it's going to level off, which gives us this more of an S-shaped curve. Here we see the logistic growth formula. So R max times N, same thing we saw in exponential growth. But now we've added in carrying capacity. K minus N over K. This is looking at how close is the population size to the carrying capacity. So as N approaches K, we're going to see a decrease in our population growth rate. And again, more math. So pause the video and see if you can solve it. So you should have gotten 10.05. So if we're to sub it into the equation, you've got 0.34 times 300 times 1/4, which gives you 10.05. AP Bio Penguins just says S. Bye, y'all.